Okay, friends, so in this video, we're going to talk about absolute value inequalities. What a great day to be you. Okay, so what are we really talking about? We're talking about things that look like this. So I've got absolute values and, an X or a variable and then an inequality sign. Okay, so I want to just tell you the punchline to this not actually funny joke. There are two keys to solving absolute value inequalities. So I am just going to repeat this over and over because these are kind of confusing. So when you get stuck, refer back to the keys. So first things first, always have the absolute value to the left side of the equation. And the second thing is that the setup to solve is really dictated by the direction of the inequality. So you either have the less than direction, this is less than or equal to, or we have the greater than direction. So this is the greater than or equal to. So you're either in this category or in this category as long as your absolute value is on the left side. So this might require a little bit of memorization on your part. You might even want to just have like a little guide for yourself as you're first learning this, just to remind yourself of what you need to do. Okay, so let me just tell you now, what are the setups? So there's two different ways that this can work. So I could have some expression here, so we'll call this expression P. So this expression is an absolute value and it's less than or equal to K. It could be less than or equal or less than K, just so long as P is on the left and then we're going the less than direction. The setup is like this. It is this three-part inequality. And so if I'm using less than or equal to, then I'll keep that less than or equal to. If I'm using less than, then I'll replace everything with less than. So this is the first setup, okay? And the second setup looks like this. So if I have my expression in absolute value on the left, and then I have greater than K can be a number, and it could be greater than or equal to or greater than. Here's the other setup. It's the expression is greater than or equal to K, or second inequality, P is less than or equal to negative K. And you can flip these for less than and greater than, so it doesn't matter. Okay, so I'm telling you all the keys to this, and I want you to have this as like a little quick reference for yourself. Because if you know these things, then as I continue to explain these other parts, hopefully it will, start to kind of solidify in your brain, because this is kind of a weird thing, I guess, to work on. So the first thing I want to do now that I've told you the setups is I want to look at these setups in context to see why. Why is this the setup? We can understand why this is. Okay, so let's think about the idea of the absolute value of X is less than 3. Okay, so I want to think about really two different ideas here. I want to think about what numbers would be solutions in this case and what number would not be solutions. And I know when you first look at this, you're kind of like, oh, it's less than, I understand this. So here's the thing. Absolute value makes this kind of funky, all right? So think about a couple of numbers that would actually work. So like usually people first think of like 1 works, 2 works, 0 works. Okay, so I'm just thinking of a couple of whole numbers that work, but there are also some other whole numbers that work. So -1 would work, -2 would work. So would 3 work? 3 would not work because this is a less than, not a less than or equal to. Okay, now here's where this gets funny. Would -5 work? So think about it for a second. I have the absolute value of -5, that equals 5. Is that less than 3? No, it is not. So here's something kind of funny about this. This is why this is crazy with the absolute value. So not every negative number now works in this. It's very specific negative numbers. And so -5, since when I take the absolute value of it, it actually makes a number greater than 3, -5 would not work. So this would not be a solution. Of course, 5 would also not be a solution. Other things that would not be solutions would be like -3 and 3, -4 and 4. So what we're getting at here is there's actually like this very small interval of solutions, right? Because I actually can't use a lot of the negative numbers. So now what I want to do is I want to think about this in the context of a number line. So let me get rid of this. And okay, So let's just graph now what the solutions can actually be. And the number line is very helpful for visualizing this. Okay, so here's 0, 1, 2, 3. Let's see, I'll go to 4, -1, -2. Let's see, I'll just go to -3 here. Okay, so we said that 0, 1, 2, -1, and -2, those are all solutions. But once we get to, and really anything up to 3 or -3 would be a solution, right? So if I'm thinking about this now, I can really go from here to here. The only thing is I just can't include 3 and -3. So I am going to use a round bracket for each of those. In fact, I will use a different color just to make that nice and clear. Okay. So then notice, so all this stuff out here and all this stuff out here are not solutions, right? So one way to represent this set of solutions would look like this. So a way we could express this without absolute value would be that x is between -3 and 3 non-inclusive. And this is the exact setup for how to solve this. So this is why that's the setup. And in interval notation, so just to remind you of the interval notation, so we read it like a book. So we start at -3, but we don't include -3, and then we go all the way to 3. So here's my number line, here's my interval notation. And like I said, another way to represent the number line would be like this. And that is the setup of how to actually solve. Okay, so that's why this setup is what it is. So now let's take a look at the other setup. So now I'm going to say what happens when the absolute value of x is greater than 3. So let's do the same thing. Okay, so I actually think that this is a good exercise for you to really understand this. So if I were you, I would pause and maybe just like try to think of some things that are and are not solutions for a moment. Come up with some both positive and negative numbers to figure this out. I think it's a really helpful exercise for you. You can hit play when you're ready. Okay, so things that would be solutions in this case. Of course, 3 is a solution, 4, 5, etc. But here's what's kind of crazy now. -3 would also be a solution, -4 and -5, right? Because the absolute value of -3 is just 3. And so 3 is indeed greater than or equal to 3. So there's actually a bunch of negative numbers now that count as solutions. And then things that are not solutions, well, of course, 1 and 2 and 0, and also -1 and -2 would not work. So there's like this little set of things that are not solutions. But I think the thing that's kind of weird about this is like when we think about greater than, we wouldn't think that like the negative numbers would necessarily work. And again, it's because we're using this absolute value. Okay, so now let's visualize that on the number line. And let's see. I'm going to mark this as 0. I'm going to mark this as 3 and 4. So I've skipped some numbers. This is not drawn to scale. This is -3, -4. Okay, so let's just mark then where our solutions are in this context. So 3 is included, 4 is included, really anything after 3 is included. So everything this way is included. And then -3 and really everything this way is included. And in this case, since we're using a greater than or equal to, that's going to give me the square bracket. I guess once again, it's a lot of white on the screen, so I'll just back that up with this pink color so you can see. Okay, so now another way that I could express this without absolute value, but with inequalities, would be that this side here, actually, let's go from positive to negative. So this side here are all the values where x is greater than or equal to 3. And then this side here are all the values where x is less than or equal to -3. And so this is the general setup for a problem, right? So that's where that comes from. And then how would we express this in interval notation? So I'm starting here. So this is negative infinity. So I go from negative infinity to stop here at -3, include -3. And then I make this jump from -3 to +3. So I'll use the union symbol. And then from 3 to infinity. So there's your interval notation. Okay, so now let's do this in the context of some actual problems. All right, so we're going to start with one that's pretty straightforward. I've already got the absolute value on the left, and then I've got a less than 6. Okay, so as long as this is on the left, then you really just refer to which case are you dealing with? This one or this one? Well, I'm dealing with something being less than 6, so this is going to be my setup. So it's all dictated by having the absolute value on the left, and then whatever inequality you have here, and that's going to be what it is. So my setup then is going to look like this. So there's my setup to actually solve this. And now I'm going to go through solving for x. So when you have a 3-part inequality, so really you're just going to think about what do I do to solve for x? So the first thing I would do is I would add 4, and then you're just going to do that to all sides of the problem. So I add 4 to all sides, and so now I've got, just -2 is less than 2x is less than 10. And then I can divide all sides by 2. So I have -1 is less than x is less than 5. Okay. And so the next thing that we have to do is we've got to put this on the number line. So if I put this on the number line, this really means that x is now between -1 and 5. So I am going to draw my number line. Here's -1, here's 5. I'm not including those numbers, so I'll give them round brackets. I'll do this in, let's do this in this green color. So round brackets or open dots, it doesn't matter. And then you can shade there. So there's our number line. And then the interval notation for that will be from -1 to 5. Okay, so now let's compare that to another example. So in this case, so my absolute value is on the left, and this is now talking about a greater than case. So when I go back to this reference sheet, greater than means this type of setup. So long as it's greater than or equal to. Or sorry, greater than or equal to. Flip-flopping it, sorry. Okay, so for this setup then, it's going to look like this. 3x plus 6 is greater than 9, or 3x plus 6 is less than or equal to -9. So notice that I both flipped the inequality and made this negative. Okay, now you just solve these two different inequalities. That's it. So I'm going to go ahead and I'm going to subtract the 6 from all sides. So now I have 3x is going to be greater than 3, or 3x is less than -15. You can go ahead and divide all sides by 3. So I get x is greater than or equal to 1, or x is less than or equal to -5. And so now, what do we do with the number line? Well, in this case, so here's my -5. Here's my 1. So I'm really just graphing each one of these inequalities. So if I start with x is less than or equal to -5, so here's -5, this is going to be the direction that I want to go. So I will use, again, I'll use the green color. So in this case, -5 is included, right, because we have the or equal to. And then I'm going to go this way. So this is everything that's less than -5. And then I'm going to graph this other inequality, x is greater than or equal to 1. So 1 is included. So I use a square bracket, and then I go this way. Okay, so there's my number line. And once you have the number line, I think it really helps with the interval notation. So now my interval notation will start here. So that's -infinity, and then it goes all the way from here. Doot, 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 doot. I hope you make the sound effect. Leave a comment if you made the sound effect. And then union 1 to infinity. All right. Bada bing, bada boom. We're good to go. Okay, so now hopefully you've kind of, this is like the basic idea. So now we're going to kind of throw you into this. So for this one, the one thing I want to point out is, so our setups are very literal. So I have to have the absolute values isolated and on the left. So you'll notice that with this particular problem, I have absolute value of x minus 5 minus 4 is less than or equal to 6. So the first thing, before I can do anything else, the very first thing I have to do is I have to isolate the absolute value. So this is actually just now going to be less than or equal to 10. Okay, so now what I want you to do is I want you to lean into this and I want you to try this yourself. So just write down what you think the setup for solving should be, and then hit play when you think you've got that to check. So the setup, so this is a less than or equal to. So as long as I'm less than or equal to, like I am here, this will be my setup, okay? So this is negative 10 less than or equal to x minus 5 less than or equal to 10. And then to finish solving, well, actually, you know what? Why don't you finish solving, and why don't you do the number line and the interval notation, and then hit play when you think you've got it. Okay, so now I'm going to go ahead and add 5 to all sides. So this is negative 5 is less than or equal to x less than or equal to 15. So here's negative 5, here's 15. So these values are included. So I'm going to use square brackets, color in between, and then my interval notation goes from negative 5 to 15, and I'm inclusive of those. Okay, so let's keep going. All right, plot twist. So now I have 5 is greater than or equal to absolute value of 3x minus 4. So remember, one of our keys was that you have to have the absolute value to the left side, because if you don't, then it messes up the setup, because these setups are actually so literal that we even have the absolute value on the left side, okay? So I need to now rewrite this problem to ensure that the first key is being checked off. So this is like totally silly. You know, I know I have like a doctorate and stuff, but like this is how I actually still do this to this day. So I have my absolute value, and then I always think of this forever and ever as a mouth that's eating, well, in this case, it's eating the 5. So I write the absolute value, I write the 5, and the inequality still has to eat the same thing it was eating before. So yeah, totally works. You'll totally remember it. And now it's in the way that we need it to be. So now what I would like you to do is I would like you to do the setup. Pause here, do the setup. Let's check your setup. So the setup in this case is going to be like this. So the 3-part inequality, because this is a less than, and again, I just keep repeating this, right? So this is less than, this is the setup. So less than or equal to or less than, this is the setup. That is the whole idea behind this. So, all right, why don't you go ahead and solve this, put the interval notation, number line, all that good stuff, hit play when you're ready. Okay, so I'm going to go ahead and just solve this. So let's see, I'm going to end up having fractions in this case, or a fraction. So let's see, my x is going to be between negative 1/3 and 3. So my number line will look like this. I include, so I'll use the square brackets or a closed dot, whichever you like. Okay, so there's my number line, and here's my interval notation. Okay, so let's keep going. More plot twists, dun dun dun. Okay, so in this case now, the first thing that I want to do is I want to just get rid of the 3. And then I need to write this so that the inequality, or so that the absolute value is on the left. So why don't you go ahead and set up the absolute value and set up the problem, and then hit play when you've at least got the setup. Okay, so in this case, I've got the absolute value of x minus 4 and 4, and our inequality is eating the absolute value, so we will maintain that. And then this is a greater than. So when it's greater than or equal to or greater than, I use the or case. So this is why this sheet is like so important, like having this written down to help you kind of get through this. You might find it helpful. So I'm going to have x minus 4 is greater than 4, or x minus 4 is less than, just less than, sorry, my bad, negative 4. Okay, and so then I can add 4 to all sides, so I get x is greater than 8, or x is less than 0. So if I set up my number line, here's 0, here's 8. Okay, so I don't want to include 0, so I'm going to use a round bracket, shade this way, and then from x is greater than 8, I use a round bracket and then go this way. So my interval notation starts at negative infinity and goes to 0, and then we make a jump, so I use the union, and then I go from 8 to infinity. Okay, so here is one more. So why don't you try this one from start to finish? And I'm going to just let you know there's one extra twist in here that I haven't mentioned before. So I'm trying to keep you on your toes. I would hate for you to get bored. So try to figure out what that twist is. Worst that happens is you get it wrong, but try this one all the way from start to finish. Hit play when you're ready. Okay, so first things first, I've got to subtract the 4, and then I've got this on the wrong side. So now I need the absolute value, or the inequality is eating the absolute value. So I write it like this. You can even say nom nom as you write that if you want. And okay, so now I set up my problem. Oh, sorry, and -2. Okay, so I actually am going to need a little bit more space in this case, so I am going to make some space. Okay, and so now to solve for x, I'll go ahead and subtract all these 8s. So now I've got -2x is greater than or equal to -6, or -2x is less than or equal to -10. Okay, here's the plot twist. When you divide by a negative and it's an inequality, the whole thing with that is that the inequality now has to flip. So see how it goes from here to here? So yeah, that's a little tricky, right? And okay. Okay, so if you got that right, woohoo, and if you didn't, hopefully now you just said you had that aha moment, so no problem. And okay, so I'll just show you now the number line. So here's 3. Oh, and I didn't flip this one. I have been doing math a lot today. So, okay, here's 3, here's 5. Okay, so less than or equal to 5 goes this way. And then greater than or equal to 5 goes this way. And my interval notation will look like this. Okay, so this is one of those videos. This video has other lessons, like slower paced lessons and examples. So if you watch this and then you're like, oh, I need to see a little bit more, just check out the other lessons and examples that I've got. I'm going to leave it at that. If you found this video helpful, consider hitting the like button or the subscribe button, or leave me a comment and let me know how it went for you. And I will talk to you guys in the next video. Thanks for watching.